Good morning all. So let us start few numerical problems on the previous topics which we have studied in our last class. Let me recall what we have seen in our previous session. So we have derived the mathematical model for three different cases. One is for sheet charge, two parallel sheet charge of infinite area, and two infinite length cylindrical surfaces and two spherical surfaces, right? So we have derived the equations for potential and electric field intensity and capacitance for all the three different cases, right? So on those three different cases, let us solve few numerical problems. Okay, the first numerical problem in this session is, let me read this. Given the potential field V is equal to 50 sin theta divided by r square volt in the free space. The part A of this particular problem is determine whether V satisfies Laplace equation. Second part, find the total charge inside the spherical shell of radius varying from 1 to 2 meter. Okay, this is the problem statement given. Let us see what all the things we need to identify. First and foremost thing, the given component is V. Potential is given, that is 50 sin theta divided by r square volt. By looking at the given statement, the potential is in spherical coordinate system. Therefore, in spherical coordinate system, the coordinates are r, theta and phi. These are the spherical coordinates we need to consider. So what is the first thing we need to identify? Determine whether V satisfies Laplace equation. That is, whether V satisfies Laplace equation means gradient square into V must be equal to 0. We need to identify this quantity, gradient square into V should be equal to 0. If it is equal to 0, then we can easily say that it satisfies the Laplace equation. If it is not equal to 0, then we can clearly say that it does not satisfy Laplace equation. That is the first part we need to identify. Coming to the second part, find the total charge inside the spherical shell. That means we need to calculate Q, the total charge enclosed within the spherical shell. So total charge can be calculated by using the Poisson's equation. By using Poisson's equation. Why the Poisson's equation we are employing here? Because the Poisson space is nothing but the place where the charges are present. Laplace space is nothing but the place or space where the charges are absent but electric field is present, right? So in order to calculate the total charge present inside this spherical shell, we need to go for Poisson's equation. That means in this particular problem statement, we have to evaluate both Poisson's equation as well as Laplace equation. Understood? So let us go for the solution of this problem. So what is the spherical coordinate representation of Laplace equation? We have seen in our previous session the spherical coordinate representation of Laplace equation is given by gradient square V is equal to 1 by r square dou by dou r of r square into dou V by dou r plus, let me write like this, plus 1 by r square sin theta into dou by dou theta of sin theta dou V by dou theta plus 1 by r square sin square theta into dou square V by dou phi square. This is the Laplace equation representation in spherical coordinate system. By looking at the potential equation given, this is 50 sin theta divided by r square, which is dependent on only two coordinates r and theta. Phi component is 0. That means this third component gets vanished. We don't want to use this third component, phi component. Only these two is enough. In order to calculate gradient square v, we need to identify the entire quantities, these two quantities. So for that, let us choose dou v by dou r first. This component, dou v by dou r, that is dou by dou r of, what is that, 50 sin theta divided by r square, right? This is the given quantity, 50 sin theta divided by r square. So this can be done as 50 sin theta is, so what is the differentiation of 1 by r square? Dou by dou r of 1 by r square can be written as r power minus 2. This can be written as minus 2 into r power minus 2 minus 1, right? So we can write it as 50 sin theta into minus 2 divided by r power minus 3 can be written as r cube. In denominator it can be written as r cube. Therefore dou v by dou r is equal to minus 100 sin theta divided by r cube. So this quantity we have identified. Multiply both sides by r square. Then this equation becomes r square dou v by dou r is equal to minus 100 r square sin theta divided by r cube. Square cube gets cancelled. What we have left? Minus 100 sin theta divided by r. Okay, this is the quantity we are going to get. Now again we need to perform differentiation, that is dou by dou r of r square dou v by dou r. This can be equivalent to differentiation of dou by dou r of minus 100 sin theta divided by r. This can be written as, what is the differentiation of 1 by r? 1 by r is, let me write here, minus r into minus 1 into r power minus 1 minus 1, r power minus 2, that is minus 1 by r square, minus 100 sin theta divided by minus r square. Minus minus gets cancelled. Okay, we left with only this much, 100 sin theta divided by r square. So what we need to do in the next step, again we need to multiply by 1 by r square. Multiply both sides by 1 by r square, because we need to evaluate entire this term, right? That's why 1 by r square dou by dou r of r square dou v by dou r is equal to 100 sin theta divided by r power 4. This is the thing, right? 100 sin theta r power 4 is the quantity which we have got. Now what is the next term? So we have evaluated this term. What is the next thing? This one. We need to differentiate with v with respect to theta. Dou v by dou theta is equal to 50 dou by dou theta of 50 sin theta whole divided by r square. What is the result? 1 by r square, 50 is constant, sin theta means cos theta. Differentiation of sin theta is cos theta. 50 cos theta by r square. So what is the next thing we need to have? The second, sine theta into dou v by dou theta, right? Sine theta into dou v by dou theta can be written as 50 sine theta into cos theta divided by r square. After evaluating this step, so what we need to do? Again we need to differentiate this. Dou by dou theta of sine theta dou v by dou theta is equal to what we are going to get? 50 divided by r square is the constant. We need to perform u into v rule. After performing uv rule, what we are going to get is cos square theta minus sine square theta. That is first into differentiation of second minus second into differentiation of first. So after solving that, we will get cos square theta minus sine square theta. Okay, what is the next step? We need to multiply this quantity by 1 by r square sine theta, right? 1 by r square sine theta into dou by dou theta of sine theta dou v by dou theta is equal to 50 cos square theta minus sine square theta whole divided by r power 4 sine theta. This is the entire quantity. Now what is the next step? We need to evaluate gradient square v. Gradient square v is sum of these two quantity. Now we have got these two quantities. The first quantity is 100 sine theta divided by r power 4 plus the second quantity is here 50 cos square theta minus sine square theta whole divided by r power 4 sine theta, right? What is the LCM of these two? LCM of these two is r power 4 sine theta. After solving this, what we are going to get? 100 sine square theta plus 50 cos square theta minus 50 sine square theta. What is the next step? Gradient square v. Let me write here. Gradient square v is equal to 100 sine square minus 50 sine square means 50 sine square theta plus 50 cos square theta divided by r power 4 sine theta. What is the resultant? If we take 50 outside, sine square theta plus cos square theta, what is that value? 1. Sine square theta plus cos square theta is equal to 1. Therefore 50 divided by r power 4 sine theta. Right? Let me write here. Gradient square v cannot be equal to 0. Gradient square v cannot be equal to 0 because gradient square v value is 50 divided by r power 4 sine theta, which is not equal to 0. That means the potential v does not satisfy the Laplace equation. Therefore v does not satisfy Laplace equation. This is the solution. Got it? Okay, coming to the second part of this particular problem. See, find the total charge inside the spherical shell. The total charge is Q. We know the Poisson's equation. We know that the Poisson's equation, that is gradient square V is equal to rho into V minus rho into V divided by epsilon naught. This is the Poisson's equation we knew, right? We have evaluated 50 square gradient square V, right? So this can be written as minus rho v by epsilon is equal to 50 divided by r power 4 sin theta. We have evaluated this, right? Then rho into v can be written as minus 50 divided by r power 4 sin theta into epsilon naught. Okay, now what is the next step? Q is equal to volume integral of rho into v into dv. We knew this equation. The total charge enclosed within the spherical shell is obtained by using this equation. That is, Q is equal to integration of what is rho v minus 50 epsilon naught divided by r power 4 sin theta into dv. What is dv? dv is equal to r square sin theta dr d theta and d phi, right? That means q is equal to minus 50 times of epsilon naught into integral, triple integral of, one is r varying from 1 to 2, r varying from 1 to 2, theta varying from 0 to pi, phi varying from 0 to 2 pi, right? So after solving this, we are going to write 1 by r power 4 sin theta into dv, that is r square sin theta dr d theta and d phi. If we try to rewrite that equation, q is equal to 50 epsilon naught integral of r1 to 2. See, r square, r power 4 gets cancelled, sin theta and sin theta get cancelled. We left with 1 by r square into dr, integration from 0 to 2 pi into d phi, 0 pi into d theta, right? So after integrating this, q is equal to minus 50 epsilon naught. So what is the integration of 1 by r square? Minus 1 by r, that is minus 1 by r from 1 to 2 into, this is phi from 0 to 2 pi, this is theta from 0 to pi. What is the resultant? Q is equal to minus 50 epsilon naught into, what is the value? Look at this. Take minus outside, then this becomes plus. 1 by r square can be written as 1 by 2 minus 1 by 1 into 2 pi into pi minus 0. So what we are going to get? Q is equal to 50 epsilon naught minus 1 by 2 into 2 pi square. 2 gets cancelled. Q is equal to minus 50 epsilon naught pi square, minus 50 epsilon naught pi square coulomb. Q is equal to minus 50 pi square into 8.854 into 10 power minus 12. What is this value? Since free space is given in the problem statement, epsilon naught is substituted as 8.854 into 10 power 4. After solving this, Q is equal to charge is 4.363 into 10 power minus 9 coulomb. This is the total charge enclosed within this spherical shell. Understood? Okay, let us solve one more problem. So verify whether the potential field given satisfies the Laplace equation. The potential given is V is equal to 3x square minus 3y square plus z square. So in which coordinate system the problem statement is given? By looking at the potential equation, we can easily say that this problem is related to Cartesian coordinate or rectangular coordinate system, right? So let me write the solution here. In Cartesian coordinate system, gradient square V, that is Laplace equation, can be represented as dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square. Since all the three components are present in the given potential V, we need to evaluate all the three components of the coordinate system. So let us go one by one. Dou V by dou x is equal to, so differentiate this V with respect to x. What we are going to get? So 3 into x square, that means into 2x, that is 6x. Dou V by dou y is equal to what? Differentiate this with respect to y. What is the thing? Dou V by dou y is equal to minus 3 into 2y, that is minus 6y, right? Dou V by dou z is equal to z square means 2z, that's it. Again, the next step is dou square V by dou x square. We need to differentiate this again. This becomes 6 dou square V by dou y square. This becomes minus 6 and this becomes dou square V by dou z square. What we are going to get? This is 2. Now substitute all the equation into this. Then gradient square V is equal to dou square V by dou x square is 6 plus dou square V by dou y square is minus 6 plus dou square V by dou z square is 2. What is the resultant? Gradient square V is equal to 2, which is not equal to 0 means, what is the meaning? Therefore, V does not satisfies Laplace equation. So let me modify the problem statement here itself. Instead of solving one more problem, let me modify the problem statement. What if V is equal to 2x square minus 3y square plus z square? Just instead of 3x square, if I give 2x square here, what is the resultant of this quantity? So dou V by dou x becomes 4x, right? 4x, and dou square V by dou x square becomes 4. Then rest of the quantities remain same. Under this circumstance, gradient square V is equal to dou square V by dou x square is 4 minus 6. Another quantity is minus 6 plus 2. What is the result? 0. Under this circumstance, gradient square V is equal to 0. That means V satisfies Laplace equation. Laplace equation. So you need to keep these things in your mind. So by using the given potential field, we can identify whether it satisfies the Laplace equation or not. So you need to remember the fundamentals of Laplace and Poisson's equations. Wherever the field, only field is present, then Laplace space comes into picture. Wherever the charges are present, a Poisson's equation comes into picture. Okay? Okay, let us solve one more problem on the given statement. determine whether or not potential equations V is equal to 2x square minus 4y square plus z square and V is equal to r square cos phi plus theta satisfies the Laplace equation. In this problem statement, we have two different potentials with different coordinate systems. The first potential equation relates to the Cartesian coordinate system. The second potential given related to the spherical coordinate system. So let us go one by one. The first one, V is equal to 2x square minus 4y square plus z square, which is straightforward. We knew gradient square V is equal to dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square in Cartesian coordinate system. So we need to evaluate all the three components. Dou V by dou x is equal to what we are going to get? 4x. Dou V by dou y is equal to minus 8y. Dou V by dou z is equal to 2z. Differentiation of all the three quantities. Okay. Dou square V by dou x square is equal to 4. Dou square V by dou y square is equal to minus 8. Dou square V by dou z square is equal to 2. Therefore, gradient square V is equal to 4 minus 8 plus 2. What is the value? Minus 2, which is not equal to 0. Therefore, V does not satisfies Laplace equation. Okay, this is the solution. First part, that is V is equal to 2x square minus 4y square plus z square, does not satisfy the Laplace equation because it is not equal to 0. Then coming to the second part, V is equal to r square cos phi plus theta. By looking at the potential equation, we know that we have all the three coordinates of the spherical coordinate system. We need to consider all the three components. In the previous case, we have neglected the phi component because V does not contain phi. But here, V has all the three components of the spherical coordinate system. That means we need to evaluate the Laplace equation for the entire length of the coordinate system, spherical coordinate system. That is, gradient square V is equal to 1 by r square dou by dou r of r square into dou V by dou r plus the second term 1 by r square sin theta into dou by dou theta of sin theta into dou V by dou theta plus 1 by r square sin square theta into dou square V by dou phi square. This is the equation. So since V has all the three components, we need to evaluate dou square V for the entire equation. So let us go one by one. That is, the first quantity, dou V r square into dou V by dou r. What we are going to get? Dou V by dou r means r square into dou by dou r of r square cos phi plus theta. What we are going to get? We are going to get, so r square into since this is constant, cos phi into 2r into 2r. So this is the thing we are going to get. So we will get 2r cube cos phi. R square dou v by dou r is equal to 2r cube into cos phi. What is the next quantity? So we need to differentiate again. Dou by dou r of r square dou v by dou r is equal to what we are going to get? R cube 3r square, right? 3r square, that means 6r square cos phi. This is the resultant. Then we need to multiply this by 1 by r square. 1 by r square dou by dou r of r square dou v by dou r is equal to 6 cos phi. 6 cos phi. Because 1 by r square and r square gets cancelled, we left with 6 cos phi. Then we go for the second quantity. What is this? Dou v by dou theta. Sin theta into dou v by dou theta. What we are going to get? Sin theta into dou by dou theta of r square cos phi plus theta. So this is constant 0, then this becomes 1. Then this is exactly equal to sin theta, that's it. Sin theta. Then we need to go for dou by dou theta of sin theta dou v by dou theta. Then this becomes differentiation of sin theta is cos theta. Cos theta. Then we need to multiply this by 1 by r square sin theta into dou by dou theta of sin theta dou v by dou theta, which is equal to what we are going to get? Cos theta divided by r square sin theta, which is equal to cos by sin is cot. Cot theta by r square. This is the second quantity. We have evaluated the entire second quantity. Then coming to the third quantity, that is dou square v by dou phi square. So we need to do dou v by dou phi first. Dou v by dou phi is equal to dou by dou phi of r square cos phi plus theta. What we are going to get? This is equal to cos phi means minus sin phi. R square minus sin phi. Then we go for dou square v by dou phi square, which is equal to minus r square sin phi means cos phi. Differentiation of sin phi is cos phi. Differentiation of cos phi is minus sin phi. So we left with this quantity. Now we need to multiply this quantity by 1 by r square sin square theta. That is 1 by r square sin square theta into dou square v by dou phi square is equal to minus r square cos phi divided by r square sin square theta. R square gets cancelled. Cos theta divided by sin square theta we have left with. Then this can be written as cos by sin is cot minus cot theta divided by sin theta. This is the resultant of the third quantity. Now the evaluation of gradient square v is equal to sum of all the three quantities, this one and this one. Then this is equal to 6 cos phi plus second quantity cot theta divided by r square plus third quantity, that is minus cot theta by sin theta. Is it equal to 0? No. this is not equal to 0. By looking at the equation, this is not equivalent to 0, hence V does not satisfies Laplace equation. In both the cases, gradient square V is not equivalent to 0. Hence, both the potential does not satisfy the Laplace equation. So, these kind of problems are very, very important in your exam point of view. Please try to concentrate more on this kind of problems. Okay? Thank you.